Hello everyone. Let's find a new page. Okay, so energy harvesting thought experiments. This is a thought I'm working through right now, and I thought I would work through it by sharing it with you as I'm initially working through the thought. It is something I've given some thought to, but I haven't written it out on paper yet. Let's say we have a generator. This can be a generator. It could be an alternator. It could be a generator with, or it could even be well, it could be a motor that's powered by two wires, right? Black and a white, or black and red, positive and negative wire with brushes. It can also be a brushless motor with three wires that we can use as a generator by running it into a three, let me see. This is something I bought on Amazon. It's a bridge rectifier. It should be a full wave bridge rectifier. And this is our input right here, the three wires. This would go to the motor, right? So the motor, if this is a three wired motor, brushless motor, I would connect those three wires here, and then this is my output. My output is plus and minus. So let's say we have whatever this is, and really it's an energy pump, right? Whether it be an alternator, a generator, a brushed motor. Now if it's a motor with, if it's a motor, like a DC motor, right, DC, that has a positive and a negative wire, let's take these wires, right, so whether it be that, or whether it be going into a full wave bridge rectifier, right, which they have these with just two as well, instead of the three. I need to make sure the camera's staying focused. So instead of having three, there can also be two, right? This one has three. That's the input. But so either using this or not using this if needed, right? So on this one, if we just have two wires coming out, okay, so if we say this is plus and this is minus, I'm just thinking about something here, because I've often thought, can I change the design of the motor, right? Can I take this motor and take something out of it, or put something in it, or change it so that it'll pulse instead of being a continuous, like right now, if we put a load on this, let's say we put a load on this, right? We connect it to a battery or a light bulb, like a DC light bulb, or some kind of load, right? A load where it does work. It could even be another motor that's connected to something, right, that's doing work. When we turn this, it's hard to turn, right? It becomes hard to turn this. It becomes hard to turn this because to turn the shaft, because it becomes hard to turn the rotor because we're putting a load on it. And I think that's what can be called, I think that's what people are referring to when they say back EMF or drag, right? It's slowing down. So I thought, what could I change here? So what does everyone talk about? Everyone talks about how do we use items that are around the house right now that we all have access to for our experiments. How could we use something we have already? And I thought, well, how could I leave the motor the way it is? I'll call it a generator because that's what I want to do with this, is generate, right? But really we're pumping energy from the environment into our circuit, right? Or into our circuit, into the wires, right? I think. I don't know though. Where's the energy? How does the energy enter the circuit? How does it enter the motor when we're generating? The energy pump. Where does it move to? Where does it move? From to where? And I was thinking, what if we have, and this is where the thought experiment part of it is. Let's see. So here I'm going to have, this will be a wheel that turns, right? This will turn. Okay. Let me think about this. And then here, there'll be a connection, right? There'll be a contact. Okay, that's our wire. Now this could be, I don't know if it'd be on the plus side or the minus side, but I could try both, right? It would be easy to change that to plus or minus, right? Because we could just as easily connect the negative wire there. And then, so then we're going to go to our battery, whatever battery this may be, right? But for now, we'll call it a 12 volt battery. That's a 12 volt battery, okay? For now, for the moment. And this is our generator, or energy pump, ambient energy pump. But it's a generator, it's a motor, it's a brushed motor. When we spin this, if this was connected directly to the battery, and we'll say this is plus and this is minus, and this is the plus. So if this was connected directly to the battery, if this was one continuous connection, and then the negative, oh, that's my negative wire, whoops. Okay, let's just, what we'll do is, since it's already there, is we'll just call this the negative right here. Okay, so this is not negative. This is our positive, that's our negative, because that's the negative wire right there, right? Okay, so the negative wire goes directly to the negative of the 12 volt battery, and the positive wire goes, it has to go to this, right? It has to go through this. Now, if this is spinning really fast, what happens when this circuit, if I say, is completed momentarily? What comes first, volts or amps? I think amps come first. If amps come first, right, before the back EMF builds up, if amps come first, that's good for the battery, right? Because we need that. We need to charge that battery. I know Don Smith calls amps resistance, and we don't need, do we need resistance? Do we have to have the amps there? Maybe we don't. I'd be very interested in what G Batteries thinks about this, and I may ask them. gbatteries.com, that's a very important place to study everything they have on their website. One question I have is, what is here? Is it a brush? Do I use brushes here? And is there going to be a spark there each time it passes, right? Because we don't want this to wear out very fast. I don't want this to wear real quickly, right? But most importantly, I want this to work, right? We can improve materials later, maybe. Now I'm going to change the subject for a moment slightly by saying another thought I have is there a way to use magnets here where there doesn't have to be a contact? It can just be a magnetic field, right? Let me think about that. That might be a test to do, right? It could be north facing north and north facing north, or north-south, north-south. And what does it do to the circuit? What happens to the voltage if this is spinning? But going back to this circuit where we just have the generator, which is the ambient energy pump, which is a motor, a brushed motor, a regular brushed motor, right? Just a regular DC motor with two brushes, or sometimes they have 4 brushes. But it'll have brushes, and it'll have a plus and a minus. If you connect that output to a meter, it'll say plus and minus on the meter. When you turn it one direction, if you turn it the other direction, the polarity changes, I think. Because of this interruption right here, my question is, how does it affect how easy or difficult it is to turn this? And can spinning this at faster speeds, or at what speed can I spin this? Can I turn this here? Does this become easy to spin? If at all, right? But this is something I'm thinking about and something I'm interested in. Because the less back EMF, the better. But there's a lot of people on the internet, on social media, that are sharing all the different ways they've achieved reduced back EMF, or when this is working, when this is doing work, to make it easier to turn, right? This isn't the only way, just having what Tom Bearden called a short circuit. It's not the only way. I would also be interested to know what Tom Bearden thinks about this circuit right here. And again, this is one test, right? And in this test, there's brushes here that make this connection. So maybe this is metal, and these have brushes here that touch the metal. Or it can be the opposite. This can be, wire can be connected to metal, and then this could be the brush. When I say a brush, it's a brush that can conduct electricity, like used in motors, right? Brushes like that's used in there. Or some other improved kind of brush, or something that can transfer that energy efficiently. But we could also probably just use the wire for the initial test, just the wire itself rubbing against metal, right? And this could just be a regular iron rod from the hardware store that's mounted on, let me think about this. I don't know that it has to be mounted to something, but it could be mounted against plastic or wood, against that. There's a lot of ways this can be made and done, but the idea is interrupting the circuit and having it connect and disconnect very, very fast. And how fast can we spin this? Can we spin this thousands of RPMs? Right, thousands? How many thousands can we spin this safely, though? This might need to be enclosed. When we have things spinning, we want to be protected. So we need eye protection and body protection too, as well. Now, if this is an alternator, so let's do this. So let's do the same. Okay, so this one we're calling a generator, right? And so I'm going to cross out alternator for the moment, and I'll put it down here. Just we'll do a separate drawing for alternator. So alternator. Okay, for alternator. Alternator already has diodes in it. They're built in. So what's coming out? I don't know. I don't see any capacitors in alternators. I haven't seen capacitors in alternators. So I'm thinking it's going to be pulsing. It's going to be a pulsing DC, right? If we can call it that. So this is our alternator, and if it has diodes in it, I think what comes out will also just be a plus and a minus, right? But to make the alternator work, that has to have energy going in to charge the field to make it work. So I'll have to talk to someone that knows how to do that and can, if I say activate the magnetic field. I would like to be able to control how strong that field is manually with what I think is called a potentiometer, where I can control how strong that magnetic field is, because I would like it to be very low. And I've read some people using as little as 4 volts going into that field, 4 or 5 volts going into there. With how many amps, I don't know. Is it milliamps? Can we put milliamps into that field? And then when we spin the alternator, when I spin this to charge a battery, right? So with this alternator, if it already has diodes, I'm not going to have to go into a full wave bridge rectifier, because it already has diodes in it, and that's what a full wave bridge rectifier has. It has diodes in it, which converts AC into DC, right? And if there's no capacitors, it'll be pulsing AC being converted into pulsed DC. And that makes me wonder, is a car alternator Tesla impulse technology? Is that what it is? I wonder. It looks like it to me. It looks like it could be. Interesting thought. So on this one, let's go with a higher voltage battery. This one we'll call fully charged. So we'll call this a 48 volt. Okay, nominal. I think that's the word that's used. Nominal. And then, but fully charged will be 54 point, maybe 5 volts, right? And I'll say fully charged. And that's what the charger will say too. The charger will say 54.5 volts. This is what my electric bike battery says. It says 48 volts. And then the charger says 54 volts. So I'll say fully charged. Okay. Here's our alternator. Now this time, just for fun, we're going to make the same wheel, but just as a variation of the first experiment. Let's say this is our, we'll say this is our plus still, and this is our minus. But this time we're going to have the minus go through the wheel here. Or the metal bar, right? So the minus will go here. We'll say this is our minus here and our plus here on our battery. So this is our minus, and the minus will continue over to the minus pole, right? And then the plus side, and we'll go over this wire. When you go up like that and down, that means we're going over it. So these wires don't touch. And we'll go over to the plus pole of the battery. So in this one, the plus is going directly to the battery from the alternator, and the minus is going through this pulsing, right? This pulsing. How fast do we spin this? And also, maybe we'll spin it the other direction this time, because we learned from MIT graduate and researcher I cannot think of his name at the moment. It'll come to me. But he made the N machine. The man that made the N machine, N. So N, like nuclear, and then machine, N machine. At the moment, I'm not remembering his name, but we could look that up. So N machine researcher, inventor, and researcher talked about spin. What happens when we spin something? So I'm applying spin to this now, right? But he talks about how does spin affect gravity, and how does it affect, if I say inertia. But we could also ask how does it affect the vacuum energy, or we can say the 0-point field, or we can say tachyon waves, gravity waves, and virtual particle flux fields. How does spin affect that? And how does spinning magnetic fields affect that? So what's happening here, right? This is just a metal rod making the connection between the alternator and the battery, but it's spinning, so that interruption, that connection is being interrupted. Now there could also be more connections. I could have another connection here, so that it connects here and there, right? So 2 connections for every 1 turn of this wheel. Right now it just connects, let's see, oh no, right now, let's see. Oh, it already connects twice, so I think then it would connect even more than twice, because right now it connects, so here's the top, it connects there, that halfway around, and then when it completes that turn, it connects again. So it connects twice for every 1 turn, right? It's completing the circuit twice for every 1 turn. And if every time it connects, it's sending an amp pulse to here, right? And then the volts follow, if I understand correctly. But have we reduced back EMF by doing that? This is my question I have. So I'm going to do this in an experiment. I just wanted to share my thoughts and work this out in my own mind as I share it with you, which is my favorite thing to do. I encourage everyone to continue to share your thoughts, because everything I do comes from inspiration from you, from the world. We all live in the world together. We all live in the universe together. It's a very creative place. In fact, it is pure creativity. Okay, so for now, I'll end this video, but that's the thought I'm thinking about. And also, what's the simple way to do this? Is there something that already exists that can act as this? So I don't have to make a rod and a piece of wood or plastic. Is there something that would complete the circuit that I can rotate, right, like this? Could I take a generator or motor and take parts out of it and use the brushes where it would complete the circuit by spinning it, right? It would be a connect, disconnect, connect, disconnect, connect, disconnect as it spun. And can I just use the brushes of a motor like this, right? Which is just a brushed motor. Could I take parts out of it and solder the coils inside, or in some way that would allow it to connect, to make that connection, and then disconnect, and then connect and disconnect, right? So like between the brushes, between 2 brushes, it's disconnected on both sides, but at one point it completes the circuit, right? That might be a way of using a motor like this right here. That way I just spin that motor here, I spin it with something, right? And then it does this. It allows that circuit to be interrupted and to reconnect and interrupt and reconnect. Now there might be big sparks here, and I don't know how long that would last and what kind of materials I could use. One thought also is to use bearings. If this metal is flat with this surface here, right, and this rod goes into this material, whatever that is, whatever this may be, if we just drilled a hole through all the way through that and then slid the rod in there, and then we rolled a bearing, right? Let's say this has a bearing or a bolt with the bearing connected to it, and there was a spring pushing against this wheel, and the bearing just rolled against this on both sides. That might be another way of doing this without using a material that will wear out quickly, such as a brush. I don't know if brushes will wear out quickly, but I'm concerned about the sparks. Whatever is used will probably have a spark there. I don't know, though. Maybe it depends on how fast this spins. One question might be, the faster this spins, is there less of a spark or more of a spark? And then how fast can we spin this, right? Because we know the faster we spin this is the more energy we pump into this battery. Anyway, have a great day. And for now, thank you for spending your time with this video. And I look forward to watching your videos and reading your writing of inspiration.